In modern history, through all the wars that have been, and the ones that ended before they started, different forms of technology have been produced for wartime use, and perhaps the most unforgettable has been the atomic bomb. However, a few other futuristic technologies have developed for over 100 years. The railgun is the most powerful land weapon in the world. A railgun is a motor device that can typically be designed as a weapon. It can come in different designs, but most images around the internet show it as a type of tank. It uses electromagnetic force to launch high-velocity projectiles. It is one of the most powerful conceptual long-range weapons that can be used on land and sometimes fired from the sea. It was the first projectile to use electricity. The massive electrical currents in the railgun create a magnetic field that speeds up the movements of a sliding armature between two rails extending out of the contraption. It is this action that launches these projectiles at full force. An electromagnetic railgun can launch at a blitzing speed of about 4,500 to 5,600 miles per hour, obliterating everything in its path. Before we proceed, please hit the subscribe button to become a part of our community and watch more interesting videos like this one. Railgun technology is not a new innovation. In fact, the very first idea of the technology was conceived in France in their century-old squabble that occurred during World War I. The technology was considered mind-blowing by the superpowers of the time, such as the US Army, Russia, China, India, and the Nazis in Germany. Hence, it led to a flurry of developments on all sides to build this world-wracking war weapon that could instantly end ground battles. In fact, the presence of this weapon on the battlefield would end wars before they start. The US Navy, in particular, took the trend recently to build their own railgun. It was a long-time initiative, and they are taking it off the ground now. Instead, this piece of weaponry will be attacked by all of the US-owned destroyers. They started working on it back in 2006, and after some 15 years and $500 million spent on research and development, progress slowed, and all attempts at its manufacture would cease in 2021. However, a new initiative is trying to breathe life into the railgun project again. And it is particularly important considering the crazily advanced weaponry that some countries already own, which could threaten the peace of their neighbors. On this note, as part of its multiple measures to reinforce its defense from armed incursions, Japan reached out to the United States for a partnership on reviving the railgun program. The purpose is simple. The partnership aims to give birth to a weapon powerful enough to counter hypersonic weapons. They have found that the ability of the railgun to shoot non-explosive projectiles over long distances is an effective form of defense against these classes of weapons. The proposal met mixed feelings because in all of history, no army has been able to field a working prototype of the weapon. However, the new program is set to do the impossible, and a report suggests that Shigenori Mishima, a representative of the Japanese Ministry of Defense's Acquisition, Technology and Logistics Agency, has officially confirmed that the railgun is now a priority listing of the Japanese military research. As it would be revealed along the timeline that the US Navy tried to build their own railgun, Japan's military had been researching the technology for about 10 years. Considering the degree to which the US built the weapon before the project fell away, a partnership with the Western nation would help to bring the technology over the finish line. Some key features that the US could bring to the deal include the high-end guidance system and power storage that will make the weapon more efficient while Japan builds the rails. Outside the influence of the US Navy, Japan sought partners in the US, such as BAE Systems and General Atomics, to open up the door of interest in the program. However, the involvement of the US Navy is inevitable, considering that BAE Systems was the primary contractor across the 15 years the US spent trying to field a railgun. Therefore, whatever technology and blueprint they want to share with the Japanese should belong to the US Navy. Also, General Atomics was the contractor the US Army asked to help research land-based railguns. They were instructed to look at how it could be fitted on a tank or any form of long-range artillery. At least, this was the case until they cut off the funding in 2021. The reason for cutting the funding was, in the quote, to free up resources in support of other Navy priorities, which include improving offensive and defensive capabilities such as directed energy, hypersonic missiles, and electronic warfare systems, according to a publication made by the US Navy when they announced the cancellation in July 2021. The new focus of the US Navy is the direct opposite of what the Japanese want. They want to use it to defend against attacks from hypersonic weapons. They see the same initiative as the US Navy to use it as land-based weaponry to defend their islands and against onslaughts from the seas. They believe only railguns can defend against highly maneuverable hypersonic missiles and aircraft that can go Mach 5 and higher. The railgun can be designed to go at that speed as well. Japan aims to force the US back into considering the weapon by formally demonstrating and reminding them about its potential. Perhaps this project is more of a pain point for the US Navy, having spent so much money, but we can only achieve a 32 megajoule railgun in a laboratory setting. Even at that stage, the return of its performance was exceptional. It could reach potential distances of 220 miles at Mach 7.5, which is 10 times farther than a typical ship-mounted gun, according to a press release by BAE Systems. It all seemed good on paper, but the insurmountable challenges arose in the project's second phase. This was where they were supposed to deliver a working prototype. However, many technicalities surrounding the railgun's overheating, which they could not overcome, led to the overall crash of the program. Of course, it would have finally been solved if it had been given more time. The deal with Japan could push the boundaries of this technology beyond where the US stopped, and it could be a win situation for both nations. Tim Painter, the spokesman of BAE Systems, received a circular from the National Defense Committee asking BAE Systems when the railgun program is likely to mature, and he further confirmed the possibility of achieving success with the collaboration with the Japanese government and the US Department of Defense. General Atomics, for its part, started working on the railgun technology in the early 2000s by teaming up with the Army to build a railgun that could be a mobile cannon or a part of a tank. In 2018, they received a 3-year contract from the U.S. Defense Department's Ordnance Technology Consortium. The assignment was to evaluate and mature a railgun weapon system, capabilities in support of the Army Armament Research, Development, and Engineering Command. They delivered a 10 megajoule medium-range railgun weapon system, tested at the Army's Dugway Proving Ground, Utah. It was thought that the weapon could shoot projectiles up to 60 miles. Eventually, the funding got cut off simultaneously with BAE Systems. Over that time, the company continued to invest in research and development of the technology even without a contract. Like BAE Systems, they too have had to answer to the U.S. National Defense, stating their interest in representing the U.S. interest in applying the technologies developed, already for the benefit of both the U.S. and Japanese governments. With regards to the potential of the railgun to defend against a hypersonic weapon, certain questions have been posed about its efficiency, seeing as it has never been fielded in actual combat before. It boiled down to a question of the physics behind it. It has been stated that a missile fired at another must have at least about 3 times the maneuvering ability of its target. The incoming missile is geared to naturally outmaneuver and evade any defensive system. The average projectile system in existence can only go about 4 Machs at the same time. The laboratory tests have shown that the railgun can fire its electromagnetic projectiles at Mach 7.5, making it theoretically liable to outmaneuver a hypersonic missile. However, whether the technology will finally overcome the overheating issue is still inherently unsolved. Likewise, the energy required to use the railgun must be evaluated. A typical railgun will demand significant power, and that requirement may not always be met due to unavailability. When the required power level is available, the problem is that it also goes into heat generation, and then the structure can get very hot. These two challenges cancel out any of the positive results observed so far. These two issues primarily stopped the project from making headway in the first instance when the Navy wanted to integrate them into destroyers. To solve the power problem, they had to find power on board the ships. Suggestions from analysts stated that the challenge posed to the Navy on the ships led to the Army's disinterest in the land-based version besides the overheating issue. The land-based version could easily use a high-powered battery and serve its purpose of countering air missile and long-range strikes. It could also tap into local electrical sources as well. In another light, the ability of the railgun to self-destruct is also something to consider. The extreme electromagnetic forces deployed on a projectile tend to act against the material of the railgun structure itself. It can either weaken the materials gradually or dislodge the key holding parts, and the weapon requires high-cost maintenance. So there is a big if that comes with the railgun technology now, and that is if the technical issues can be worked out, it might work as applied. The railgun would be much cheaper than conventional munitions, which require expensive propellants and are costly to produce. In contrast, the railgun only needs a solid piece of metal to do damage, while relying on the mass and velocity of the projectile. The US Navy has yet to formally comment on the progress of things if they are ready to throw in the buck once more to push through this exciting piece of war tech. Do you think the railgun will finally become a reality? If it does, it will change the scope of warfare forever. Let me know what you think in the comments. See you in the next video.